I chose my A value is 90 and my B value is 300. To the problem, we must use the parametric equations x equals v naught cosine theta t and y equals negative 16 t squared plus v naught sine t plus c. Based on the problem, we know x, v, and c. X is the B value we chose, which is 300, and V is our A value we chose. The A value is 90, but the problem says the velocity has to be in miles per hour, so our velocity becomes 32 miles per hour from the 90 value. And finally, C is 3 because the problem tells us it is. So the equations now are 300 equals 132 cosine x t, and y equals negative 16 t squared plus 132 sine x t plus 3. To find the theta, theta or x in this guy, substitute for x, we isolate t in the first equation and use substitution. So t equals 300 132 cosine x, or theta. We plug that t value into the second equation as you can see here. To find out what theta would equal, we would graph this equation and put x in place of theta, and there would be two x values because this is a quadratic. So the x values would be 16.087 and 73.34. To figure out which one we use, we'd plug these values in as theta and solve for t. For 16.087, the time is 2.36. T is 7.927 when 73.34 is plugged in. In this scenario, we would go with 16.807 because it creates the smallest time. The problem is saying that baseball is asking when a baseball hit the ground, so 2.36 is more realistic.